Welcome audience to this video on line balancing and operation management. It entails a little bit of a mathematical orientation. I would request the audiences to watch this video repeatedly. If you don't understand, watch it slowly, pause it. At times, there would be charts and you need to understand those things once at a time. So definition, the line balancing is a procedure in which tasks along with the assembly line are assigned to the workstation so that each of them has approximately the same amount of work. So either you divide the work equally at each workstation so that everybody does have the same amount of work, nobody can cry, nobody can crave, and they come up and all the works are completed simultaneously. So that's one of those balancing act that we would like to do around it. But is it that's an ideal situation, but is it possible in real life situation? Probably no. So we have a problem with line balancing. The objective of line balancing is to assign tasks to minimize the worker's ideal time, rest time, wastage of time. Therefore, ideal time cost and meet the requirement production rate of line. In a perfectly balanced line, all workers would complete their assigned task at the same time. When I said equal amount of work been assigned to equal of the workers, and everybody will work, finish, and more or less the same time. But this is an ideal situation. In real life situation, simply not possible. There would be no ideal time in this ideal situation. Everybody would be busy with their work. But unfortunately, there are a number of conditions that prevents from actually achieving the perfectly balanced line. What? The estimated time of task may vary. The speed at which the worker is working may vary. The precedence relation to the task. I can only start my task only when the precedent work task has been completed. I'm waiting somebody else to finish their task before I start proceeding. Someone else is waiting for me to complete the class before he or she starts proceeding with the task. The combinatorial nature of the problem, as the case might be, it's a complex problem. That's the reason why we have to have a lines balance problem. The workstation ideal arrangement should be that one completes the other, completes the other, completes the other, completes. So it becomes an input. The completion of the task for this gentleman becomes an input for this gentleman or this workstation for this lady or this department, and so on and so forth. The layout design involves assigning one or more of the tasks required to make the product work. That is what we are trying to do around it. This is line balancing problem per say. Example of line balancing thing. If you look about A, B, C, D, E, F, G, H as tasks, time for completion of A task is 2 minutes, B for 1 minute, three for C for 3 minute 25 seconds approximately, D for 1 minute 20 seconds, for E it's 50 seconds, uh, for F it is 60 seconds, for G it is 60 seconds, for H it is 100 seconds. It is there in minutes. Now what are we looking into it? There are no precedences for task A because he initiates the task. It's an assembly friend. There are no precedences. But for B is the completion of the task A is very important. Similarly for C, there are no precedences. Why? Because they are assembling motor housing. None. It is absolutely none. But for D, it is the completion of A and C. A and C, when they complete, only can D start their work. Similarly, for E has a precedence of D to be completions. The predecessor for F is E. The predecessor for G is B. Remember, this is what we are trying to the mount switch or the attached cord is B altogether, and H is where is the going to test. It is F and G. That is what we are looking at. Only when F and G are complete can H go ahead and test the product whether the product comes out with as per the standard prescribed or not. So you have been just assigned a job of setting up an electric fan, and the following task is required. Yes, but this is how the pictorial representation terms form stands for. Whatever I have just shown it to you, you can pause the video, you can reverse back, and please understand this is how it has been manned. You remember this thing that been going around it. This is the last task of G, the H. This is the A task which carries about it. Absolutely, the 1 minute, 1 minute. The point which has been presented, the time lag that comes around here. A doesn't have any predecessors. B has a predecessor called A. C has none predecessor, but D has a predecessor of A and C. Look how it has been represented. Similarly, for task predecessor, E is D. For F, it is E, as the case might be. For G, it is B. and there comes the word called H, which is the reflection of E and G. And I believe everybody is aware of what we wanted to go around. Number represent the amount of time that is required to complete the task. So Kilbridge and the Webster method, step one, draw the precedence diagram. Arrange them in a different zone so that the average time is equal or probably nearly equal to each other. So if we have a land, the balance problem, we have this, we are doing it in phases one, phases two, phases three. As a line balancing problem, look what B is doing at 3.4 minutes, you have 4.1 minutes and 1.7 minutes. So in maximum time within 5 minutes time, or should I say 4 minute or 10 seconds, everything would be over B, C, and D. Similarly, for 2.7 minutes and 3.3 minutes, within 3.3 minutes, both these tasks can be over around here. That is how we have to go around, and this is what the Kilbridge problems is all about here. Here, the ideal time is 16 minutes, 80 seconds, or 8 seconds, if I may say. So, ideal time is the percentage of 16 by 8 by divided by the last time that has been prevented by H. 9.2 into 100 gives me an ideal time which is approximately 182%. That is absolutely not acceptable. Why? When people are loitering a lot, having too much of a me time rather than on a productive time that goes around it. So what can be done? Allow me to go to the step two, is transferability. In this principle, the activities are transferred from one zone to another zone as long as they don't affect the sequences denoted by the ordered pair. Step three, from step two, and by arranging the work center, the line becomes more or less balanced. Now, what happens if this is to be the line balancing for format? If 2.2 we can start as an initiating program for A, for D and C. They start working around it. For B, it is 3.4 minutes, right? B continues to work around it because B is supposed to be only finishing the chord, needs to be finished. This is the plug point that D is trying to do, is to be given to E. So we can have another phase of C and D, which is to be completed within 4.1 minutes. And probably the assembling of the chord and the chart, and probably DNF would take 3.3.30 seconds, and the lastly it would be 2.6. Now what does it difference? Earlier time it was on the different levels altogether, we were permitting on a different scenarios. So wherein C, E, and D were doing on the same zone fashion, right? So that is what we would love to avoid. Here, the ideal time is not 16 minutes 8 seconds, but probably 4 minutes. Ideal time per percentage is approximately reduced whoopingly to two-third or 66.6 percentage, and that is what we want to try to go around it. With this, I come to an end of this video. Thank you for watching the same.